Hello, everyone. Thank you for joining me today. My name is Wilbur Albany. I'm a software developer based in Ontario, Canada, working for IBM. And in this session, we'll not just be learning how to create our first GenAI application, but also building it together. So there should be a link in the chat. It's a quick link that will take you to Cognitive Class, where it's an IBM initiative where we create and provide learning content for free. I'd highly recommend signing up for it and enrolling the course so you can work on it with me. The course is called Build Your First GenAI Application the Right Way. It's a guided project designed to kind of be done in like an hour and an hour and a half. So yeah, I'd highly recommend. Best part about it is that it's also self-paced and completely free. So what are we going to do today? We're going to create a Flask web app that integrates with not one, not two, but three different AI models, leveraging the use of Meta's Llama 3, IBM's Granite, and Mistral's Mixtral model. And by the end of the session, you will have learned how to prompt different kinds of LLMs, how to use tools like LangChain, and how to structure outputs and design reusable and modular code. So let's get started. So first things first, I'll give you guys a minute. So if you want to set up your account, the beginning is just creating the what do you call it, the file directory. So it's not super exciting, but essentially what we're going to do is that essentially this is our cloud IDE. It's a VS Code like integrated development environment, and since it's on the cloud, all you really need is a modern browser. I'm just using Chrome here. But Firefox also works just as well from my experience. So on the left side, you'll have your instructions here, and you can like open them up or close them depending on how large you want your IDE to be if you're working on stuff. And on the right side is where you have your code editor itself, and you can even have your terminal, which we can bring it up right here, and we have our terminal. And here are the instructions. You can like go through, you can skip some content, you can go back a little bit. So really it's very self-paced, and you can kind of move however you want. Even after this session, you can decide to do another one or continue this one. It's really up to you. The world is your oyster. So to start things off, we're gonna create a project directory. So you'll see we have code snippets here. So we can very well just copy this code and like paste it in the terminal, and that will run it for us. And you'll see that will create our first folder that we have here. Or you can just run the execute button right here, and that will just inject the code into your terminal and run it for you. So for the Python virtual environment, we're just going to quickly run this in here, and it's going to create a virtual environment. Virtual environments, while not strictly necessary, is highly recommended and great practice, especially if you're working with a lot of different projects that use similar libraries, but they may have a slightly different version. And that can sometimes matter, especially if the versions are have some changing differences. Lastly, for this step, we're gonna go ahead and install the IBM watsonx AI library. This is gonna be a API wrapper for the watsonx AI endpoint. And that's how we're gonna communicate through all the watsonx AI models. Okay, so I'm hoping everyone has reached this page so far. Let me know if there are any like technical difficulties going on, but yeah, I'm gonna go ahead and continue from here. Moving on. So the AI models, I mentioned a few. I mentioned Llama 3, Granite, and Mixtral. Where are they? Well, Llama 3 is Meta's flagship model. It's a successor built upon Llama 2. It's a huge improvement in Llama 2 in many tasks, definitely better context and understanding and the generation capabilities, as well as like better understanding of more nuanced prompts. However, it is a little bit like higher computational wise, especially some of the larger models, right? Yeah, and also often, from my experience at least, requires a bit more fine tuning or prompt engineering compared to some of the other models. So the best use cases for this, in my opinion, would be more advanced generation tasks and advanced understanding and applications that require up-to-date knowledge and reasoning, because yeah, Llama 3 is one that gets updated fairly frequently. Now, IBM Granite is the one by IBM, as the name suggests. It's as you can imagine, is optimized for more enterprise use cases, so more B2B, that kind of stuff. So because of that, has a lot of great performance when it comes to the business and more technical domains, and also works very well, very seamlessly with the Watson X ecosystem. However, as a result of that, kind of a double-edged sword, it may not be the most effective for more general purpose tasks compared to other open source alternatives that you may find. And yeah, so best use cases for this would be enterprise level applications, specialized tasks, and integrations with other IBM services. Now, Mixtral will be the last main one we'll be trying out today. This is by Mistral. And this is an interesting one because, as the name suggests, Mixtral uses something called the mixture of experts setup, where much like other neural networks, depending on multiple layers, Mixtral has 8 specialized quote-unquote experts, where each token, well, every time it goes through a layer, it's going to go to a specific expert, one of the 8, and the 8 best suited for this task. So this is pretty good because it allows it to be very efficient because it kind of only activates the experts that are needed for each token and kind of like turns off the ones that are unnecessary. So kind of like streamlines the process. It makes it pretty adaptable and performs pretty well on both general and specialized tasks. However, this does add an extra layer of complexity because it makes deployment a little bit more difficult and model interpretation. Because when you're choosing the expert, believe it or not, it uses a router that decides which expert it should go to, and that also uses a neural network. So yeah, it does add a little bit of extra complexity in that sense. So overall, best use cases for that would be pretty good. Like if you need adaptive systems and you need a lot of flexibility to handle a lot of different types of tasks, and you want to try to optimize your resource usage. So when choosing an LLM, you want to focus on a few different factors, or many different factors, but some of them would be like obviously speed. Depending on what you're trying to do, you might want an LLM that's a bit more performant in terms of time. So maybe something like a user chatbot, right? Like a customer support bot, right? You probably want that to be a little bit quicker, if possible, because users don't really like to wait. Accuracy is another important one. That generally goes like hand in hand with speed. Generally, the faster the model, you're going to probably have to sacrifice a little bit of accuracy at the very least. Cost, that's a little bit obvious. You want to try to get the best bang for your buck. Yeah. Latency, again, this is more related to like deployment. A lot of the AI models are deployed on the cloud. You could technically run it locally, but in most cases, you'll probably be running it through the cloud, and which is what we're going to be doing here, where we're going to be contacting the IBM Watson X AI endpoints and calling them all through there. And then specialization, that one, yeah, depending on the tasks, even if they're like the same similar models, like on paper, like they have the same number of parameters, they are trained in a similar fashion, even then, they're still, and they cost the same. Even then, there could still be some differences to consider, much like Granite being more, probably having more enterprise-related like business data, like that it's been trained on, compared to something Llama, which is more varied or more general. Okay. Is there an offline alternative to Cloud IDE? Unfortunately, no, because yeah, everything on this is the cloud, so you will have to be online for it. But everything I do here, you could do it on VS Code. The only thing is this a little bit easier here because we don't have to worry about things like computer specifications. We don't have to worry about like managing packages, and there's even the nice code snippets that you can run pretty easily. But everything I do here, you could just, if you launch up VS Code, you could more or less achieve a very similar result. You'll have to probably do a little more configuring when it comes to things like the API keys, but you'll see that in a bit. So moving on, let's actually get to coding right now. So we have this button here. It's going to open capital.py. We're going to make our first call to the Watson X. So let's make a file. You can just press this, or you could very well just right-click and hit new file and just do capital.py, and then that will create it for you. Or you can press this button, whichever really you prefer. For brevity's sake, I'm just going to go ahead and just take the lazy route and start pressing all the buttons that are available. But yeah, So with this first one here, let's write some code. We're going to import a few libraries. So this one here, we're going to import credentials, model inference, and gentext params metanames. So where are these? Well, credentials is going to be just like things like the API. That's where we generally put the API key and the URL. And you can see it over here. I'm going to copy this, and we're going to put this at the bottom right over here. So what did we just do? Well, we created a credentials object. We put in the URL. The URL, IBM has a few different options when it comes to like calling the AI models. Like this one right here is US South, which I believe is Dallas, over in the US. So this one will just call it there. There are other options. I believe there's one in London. I think there's one in Japan, Germany. So there's a lot of different like endpoints around the world depending on like where you're located to help with latency. For now, this just keep this URL because I believe the Cloud ID is kind of designed to just work with this. Now, normally you would put an API key just like this, like right here. But for now, we've kind of got you covered. You don't have to put that. But if you were doing it offline mode, you will have to set up an API key. How you do that is you have to go to the like cloud.ibm.com. You have to have an account. Kind of like AWS, if you're familiar with that, you just have to set up a cloud API key, and then you just pop it in here, and then it's going to work like magic. But for now, this is going to automatically work, but in real cases, maybe not quite like that. Now, params, these are kind of the settings for the LLM we're calling. So there are quite a few more, but for now, like two important ones would be greedy and max new tokens we're going to talk about. So greedy, it's the decoding method. So this is just how LLM selects the next token. So everything when it comes to the LLM, just like how we might break sentences down into words or letters or even sounds, LLMs kind of break sentences or even like phrases or wherever into tokens, right? And each token is not quite exactly what we would constitute like a letter. But yeah, here's an example photo. You see the sea otter one right here. It shows how an LLM breaks down. So it treats each of these as a token, and then it processes it. And the token is just like pretty much like a bunch of numbers. It's just like machine language, I guess. But this is kind of how it breaks down. And as you may expect, like LLMs, they don't really have like logical reasoning. They're more predictive, right? So they just predict what the next sequence of tokens are, and then they translate the tokens back to human language. And using the greedy decoding method would just mean that when you're it will just choose the most probable next token. So it makes it a little bit more deterministic, a bit more more predictable when it comes to what the next thing is going to be, which may or may not be good depending on what you're doing. The other option is going to be sample. So we can also just replace this with sample. This will essentially just add a little bit more randomness to it. There's something called like temperature when it comes to LLMs, and that influences how random the LLM will act. And depending on what you're doing, that might be good or not. Like, do you want the LLM to always give you the exact same thing or very, very similar? Or do you want it to be more varied in responses? Maybe if you're trying to be more factual, maybe greedy might be a good way. So it's always going to be the most accurate. But if you want to do some creative writing, right? Maybe some sampling, change things up a little bit might be nice. Max new tokens. Again, this is an optional one. Well, actually, for this, let me just set it back to greedy for now. But yeah, just so we can keep things a little more predictable. But yeah, max new tokens. This one is going to be just to limit how many tokens we use. So yeah, like depending on your response, sometimes it could really output a lot. Sometimes it could output a little bit of like data. So setting up a hard limit might be good. Sometimes the LLM could get a little bit finicky and start like outputting things like almost forever. So yeah, that's why it's always good to keep in mind how much tokens you're allocating for the LLM per activation. That way, you kind of save your wallet. Okay, we're done with params. Now the model. So here we're going to use model inference, where so here we're creating a model object. We're passing the model ID, and there's a whole different bunch. Right now we're using IBM's Granite 13B Instruct v2. So a little bit of a mouthful, not the easiest to roll off the tongue, but essentially let's break it down. IBM, that's the kind of the company or the maintainers of it, / and then Granite is the name of the I guess, the model family, not the specific model, because like even within Granite and Llama and Mixtral, there are multiple different models, right? So Granite is like the umbrella term for like all the Granite models. 13B, this means how many parameters. So this is 13 billion parameters. There are many different types of models. Some have lower number of parameters, or like some with like 1 billion parameters, and they go like up to like 70 billion or so, even higher. And that affects things like on accuracy and speed. Generally, as you can imagine, the lower the parameters, probably the cheaper it is, the faster it runs, the higher, vice versa, right? And instruct is just like a term to kind of describe what it's designed to do. With Watson X, there are two kinds. You have instruct, and then you have chat. Instruct is more designed for just knowing, like telling the LLM what to do, and then it returns an output. So you're just telling it to complete a task. That could be something like, oh, summarize this thing for me, or like rewrite this for me, that kind of thing. Whereas chat is more designed for context, like to read between the lines, context clues. So chat might be better for like a chat bot, as you imagine, because there's a lot of back and forth going on, you with the LLM, and then and so because of that, it has to read through a whole bunch of different text and keep all of that information in mind, and then like give you an answer. Whereas instruct is a little bit simpler. Just, hey, do this for me. LLM's like, sure, you got it. I'll do it for you. We're done, just like that. So yeah, as you can see, we're passing in params in here, and we're passing in credentials. So this is just stuff in here, and also project ID. This is not that important. This is just kind of related to the credentials part, where we're just saying, hey, the Watson X project folder is called Skills Network. So just like that's like the project ID. That's it's just like a memorable name for you to know what it's being used for, right? So yeah, I think we also want to put the text right here. So this one here is the fun part. This is where we put the prompts. So we're going to put in text, and we're going to run model generate text. And specifically, we just want to generate the text. Like if you just run generate text like that, it's going to give you a whole bunch of other information. But yeah, I'll show you guys as well. But let's give that a run and see what we get. And there we go, Ottawa, perfect, right? And you can play around with the text. You can try something else. You can try what's the capital of France, right? See what we get there. We can like run that again. And yep, Paris, there we go, perfect, right? So yeah, we're now properly pinging the LLM. Great, awesome. Now let's take this a step further. Let's see how far we can go with this. Moving on. Now let's try other LLM models. Right now we tried the Granite 13B Instruct V2. Let's try some other ones. Let's try Llama right here. So let's take this Llama. All we're going to do is just take this, and we're just going to replace it in here. So like that. So now instead of like IBM Granite, it's now Meta Llama 3.2 1B Instruct. So remember, Meta is the company, like Meta Llama. Llama 3.2, that's like the name of the model. It's like 3.2. 1B is the parameters, and Instruct is the type of LLM we're dealing with. Now, all we did was just change the model. And what's great about Watson X is that all the models that we're going to work with today are open source. And yeah, and because of that, like switching through them is going to be very easy. And in this case, it's just like a simple change of one line. And also, yeah, like open source is always pretty fun. You can always like look up even the weights if you're really into that, and you can really like play around with them. So yeah, let's try running it again. So again, all we did was just change this one line. We're going to run it, see what we get. And weird response, right? Like, okay, it did tell me the capital of Canada, but now it started telling me a whole bunch of other Canadian cities, and then ending it off with a bunch of Edmontons. So that's weird. So why did that happen? Is Llama just a bad model? Did Meta lie to us? No, not quite. So we missed a very important step, and I'll get to that in just a bit. But if you want to play around, you can also try with some of these other models. I have here a bunch of other models, but you could find even more on the Watson X Foundation models. Like if you just go into Google, type Watson X models, click on the first link, you scroll down, you'll pretty much find the exact same thing with a whole bunch of different models that you can play around with, and it's always constantly getting updated. So yeah, lots of new stuff. And it's very exciting. Like the LLM world is very exciting because of like how there's always something new coming out. There's always something to look forward to. But yeah, so I definitely recommend trying out. All you have to do is really just pick whatever you want. Like let's try this one right here, the Meta Llama 3211B. We can just copy this and replace the string here and try calling the thing again. So let's try calling it, see if we can get another similar response, and that broke. Oh, it might be a deprecated model actually, but yeah, hold on. Yeah, since a lot of things are always moving, some of the models may already be deprecated, which is kind of funny. But yeah, let me try one more. And there we go. Okay, this one actually works a little bit better. This one probably says Ottawa. So some of them don't work as well, and some of them do. So let's figure out why. So what we're missing is tokenization and prompt formatting. So kind of like how we have different. So Llama uses special tokens, right, to improve functionality and control and adaptability across like a whole different types of tasks, right? So without the special tokens, like the responses can be a little bit unpredictable because it lacks like the necessary cues to interpret the structure, the context, or the intent of the input, right? So these tokens kind of act as guidelines to tell the model how to respond. Let's see. So let me think. To give you a good example, like let's say if I were to ask you, or like you were an LLM, I say, why did the chicken cross the road? That's the prompt, right? Well, maybe to you, you would probably respond with to get to the other side. But to the LLM, maybe it takes that and it's like, oh, that's a common riddle. You could just say, why did the chicken cross the road is a common riddle joke that is said among people, right? And that's still technically true. It is a riddle joke, but that's not what I wanted, right? Like, as you can imagine, that's not what I wanted when I asked you that question, right? So LLMs, they don't have logical reasoning. All they can do is predict the next token. So by using this, we kind of help guide the LLM into telling us exactly what we want. So with the previous example, like what's going on, and might have been reading this as, oh, not this one. The previous example, if we run it again, what the LLM was probably doing was just listing out a whole bunch of Canadian thingies, like Canadian options, like as if it was like a multiple choice exam, right? So because like as you can imagine, if you're reading an exam, what's the capital of Canada? A, B, C, D. A, Ottawa. B, Vancouver. C, like, right? So that could be like a possibility, for example. So let's take use of this and talk about this. All of the stuff you can actually find on Llama's model card. If you go to llama.com and go to the documentation, you can find all of that stuff and like read through it. There's a few more tokens found here, but for now, these are like really the most important ones that you will need and the ones that we'll be using for today. So we have begin of text. Essentially, that just tells us start processing tokens, like start tokenizing this text and processing them. End of text just tells you to stop processing. Actually, this one's not super necessary because if the string just ends, it kind of automatically assumes that there's end of text, but could be kind of useful like if it stops in the middle and you don't want to tokenize any other information afterwards. Start header ID and end header ID, these are actually the important parts because that tells us what the LLM has to do and what it's supposed to do, right? And EOT ID is end of turn identifier, which just tells us, hey, we're done with this turn. So like this is all just like for one group. We're going to start a new group like in a bit. So this is what Llama 3 does. And remember when I mentioned that Llama 3 is generally, from my experience, requires a little bit more time for fine tuning. This is what I mean because yeah, doing this from my experience is definitely more important with Llama, even though they are actually found in Mixtral and Granite, right? They also use them. But then again, like depending on your tasks, a lot of the easier ones you can probably get by without it. And we saw some examples earlier, properly prompting it without really needing to use these fancy tokens. But they're always good to know, even for Mixel and Granite, because as you deal with more complex prompts, especially prompts that have multiple different chats, like back and forth between user and LLM, this stuff would be pretty much invaluable. So I definitely recommend reading through this page if there's some stuff like you still don't understand. But let's try the second time. And essentially, this is the updated thing. It looks a little scary, but it's not that bad. We'll like type it in together. So essentially, we're going to start with begin of text, right? So we're just saying, hey, start generating token, right? And then say start header ID, and then we're going to do another one, and header ID. And then inside, we're going to start with the first one, system. So system is going to tell who you are. In this case, we're going to say you are an expert assistant who provides concise and accurate answers, right? So we're going to say something like that. And then end of turn ID. And now we're going to also add the second header. I'll just quickly copy this. And that will be what's next? It would be user. So this would be where we ask the question. We'll say, what's the capital of Canada? Okay, and then end of turn. And then we'll also add a little section here where it will be for the, one second, the assistant. So this kind of just tells it, hey, I want you to continue after this, like after this user should be what the assistant does, and then the LLM will fill out the rest. So let's give that a try now. We're going to run it again, see what we get. And just like that, the capital of Canada is Ottawa. So this is the same Llama 321B instruct, but now it's giving us what we actually want to get, right? And you can even play around with the system context, because that's where you want to put things. Like if it's like security thing, maybe you can be like, oh, do not give out passwords or don't do anything. Like that's generally kind of what you put here, like some basic guardrails. You can even edit it like while also giving fun facts. Let's see how this works with it and see if we can get a good answer with that as well. Oh, there we go. The capital of Canada is Ottawa. Did you know that Ottawa is also the home of the Canadian Parliament, which is the country's national legislative assembly? See, that's a pretty fun fact right there. We put in the system context, essentially, rather than like the question. So just like that, yeah. Remember, again, LLMs aren't really fully equipped for true logical reasoning, so that's why we still have to kind of guide it towards what the answer we want. But yeah, maybe in the future, once AI fully really takes over and goes off, we might like it'll probably have like better reasoning than most of us. But yeah, I'd recommend as an exercise to also try with other models. I also have an example of what some other models will look like the proper formatting. So if you want to, feel free to play around with different models. So moving on, we're now going to actually dive into LangChain. So LangChain is a kind of like an abstraction layer over like a bunch of different models. So remember earlier with the Watson X, we were able to switch out different models from Llama to IBM's Granite, right? And that's great because they're all found in like Watson X. What if we want to have another one, like we want to take like an OpenAI's GPT model or one of Anthropic's Claude models, right? Then we're kind of out of luck until LangChain comes in. It solves a few different problems. So like, for example, what if I want to be able to switch models easily without changing a lot of code, Or what if I want Granite to interpret prompts, but I want GPT to write a response back, right? So that's where LangChain comes in. It's an orchestration framework for developing applications that use any kind of LLM. And it's a really good framework. It came out earlier in like 2022. And I think at one point it was like the highest growing GitHub framework. So it's definitely a big deal and it's growing very, very fast. So let's start again. We're going to go ahead and download a few libraries. We're going to use Flask, LangChain, IBM, and LangChain. So Flask is just going to be what we're using for like our web endpoints to just create a basic HTML website. LangChain IBM is just like some extra tools within LangChain's like tool base that are specifically designed for Watson X and LangChain itself, as you can imagine. So yeah, let's create the main application file. We're going to open a new file called app.py. It's just going to be in the same folder as GenAI Flask app. We're not going to really be needing capital anymore, so you can go ahead and close that. So yeah, you see from Flask, import Flask. We're going to like just copy all this stuff. What we're doing here is we're just, if you're familiar with Flask, it's kind of just like a HTTP web server. It's similar to something like the likes of like Django or kind of like Fast API, but Fast API is a bit more focused on just backend, maybe Angular, kind of, yeah, Node like Express.js. So there's a few different options here. They're all very popular, but I like Flask. Flask is very easy to work with. So yeah, essentially what we're doing, we're creating a very basic route called /generate. It's going to be a post route, and we're going to go ahead and return something here in a bit. We're going to leave that for now. But yeah, now let's actually create the model configuration file. So you will actually recognize a lot of this stuff already. So hopefully this would be just familiar to you. So while we are no longer using the IBM Watson X like AI libraries, we're going to be using more of like the LangChain. It's still going to work very similar because in the end they are both a wrapper to the Watson X AI URL. So yeah, we're doing the parameters again, same thing, credentials, same thing. And for the model IDs, I decided to choose these three. I kind of just picked them at random. You can pick really whatever you want. But yeah, these are some like good variety of models, one Llama, one Granite, and one Mixtral. Let's now make a model.py. So we're making a new file now called model.py. It's going to be in the same folder as the ones where everything's going to actually be in the same folder. But yeah, you see now we have model.py next to app, capital, and config. We're going to import ChatWatsonX. This is similar to the model inference like library that we imported earlier. We're going to have prompt templates, and then we're going to import pretty much everything we defined in config. Theoretically, we could just copy all of this and put it in model, but best practices is you want to try to separate like different types of code. So configuration, let's just all keep it its own special file, and we'll just import what we need, just like that. So it just keeps things more modular, keeps things reusable. And yeah, let's start initializing the model. Let's see. Oh, question right here. Would that include setting limitations which politely instruct and inquire when a particular question was out of bounds, and perhaps even explain at a high level why the question was inappropriate? Yes, you could definitely do that there. Doing it in like the system is a very, very more basic kind of primitive way to do it. It's not the most secure way to do it, but like for our intents and purposes, it'll be kind of fine. But for like more serious applications, you will want to set up something more advanced. We even have other guided projects right on cognitive class that I'd highly recommend taking a look. I believe there's one that uses NVIDIA recently came out with something called Nemo, I believe, which is like a pretty interesting like way to protect your company's like security and privacy when it comes to LLMs, right? So there's a lot of stuff on the cognitive class, but yes, in essence, putting it on the system could work as a very, very basic level of it. But it's not foolproof, because if you're good at prompt engineering and you're good, yeah, you could very well just get it to like tell you all the passwords with enough tries and effort, right? But yeah, moving on right here, initializing a model. Yeah, so we're gonna just make a simple function that calls the API function, the API, and returns a model with ChatWatsonX. We're passing the model URL, project ID, and the parameters. Again, this is all stuff you've seen before. We're just now putting it in a nice model that makes things a little easier, and we're putting the models like that. So now we have a Llama 3 LLM, Granite, and Mixtral LLMs, which we can just like use whenever we want. Now it comes to the prompt templates. So let's go ahead and copy this, because I do not want to write these by hand again. But again, not that scary. Don't worry. You should recognize, especially the Llama one. You see begin of text, start header ID system, end header ID. We're going to put in system prompt, end of turn, right? So boom, we just got done our system prompt stuff. Then we have our user stuff. And then we have a little spot where the LLM will respond underneath. And we put input variables. And this is really nice because keep in mind, remember with the capital.py that we tested earlier? So we have this text, but it is kind of hard-coded, right? So are we going to have to make a prompt every single time for every type of thing? That's not going to be like super easy to work with. So making this helps things be reusable. This is one of the great things about LangChain, because it takes account of that and has this prompt template that will let us actually like use this. And we can even like test it. So like we can even like print, we can do like llama 3 underscore template dot invoke, I believe. And then we can do, it's going to take in like an object, which would be the variable. So we can say system prompt, and you can say I am system prompt. And then we can do user prompt, and I am user prompt. Okay, and then we'll see what that gives us here. Let me just close this a bit so we can get the full screen. Python model.py. Let's give that a go. And fingers crossed if I did not make a mistake. There we go. So if we see this, it's going to be the same thing here. It's just that we've injected our prompt here, I am system prompt, and then I am user prompt over here. So now by calling this, we can just make things a little bit more reusable like that. So now we can just essentially kind of invoke this into the model. So we can even do like llama 3 LLM.invoke, and then we would just like pass this in. I think that will work fine. Let's take a look. Oh, forgot to print it. Oops. Here. So what we're doing is we're invoking the prompt into the prompt template, and then we're taking that and we're invoking it into the LLM. So now, yeah, it's reading it and it's got that. So there's a prompt. User prompt is online. System prompt. Okay, yeah, sure. It's just doing some other things. I guess it's like role playing with whatever this is. So yeah, like point is the LLM got pinged. So that's cool. However, I think you will agree with me that this is not the nicest way to code. Like if you see, we're doing 2 invokes. This is like a long line. So let's take this one step further and try to make it even nicer. And this is probably the best part about LangChain, because this is when the chain parts of LangChain comes into play. So we can actually combine the prompt template with the LLM. So let's make a function. So define get AI response. We're going to pass in pretty much everything we want: the model, template, system prompt, and user prompt. Right? We're going to pass in all of that, and so instead of invoking all that, we can just say chain would be template. So we're going to invoke into the model. So the pipe is the pipe operator, and essentially what LangChain uses to kind of combine the two into one. So what we would do is invoke the prompt template. So this is essentially like this part right here. And then whatever comes out of this, it will use this to invoke into the model. So then we can just do that and return chain.invoke, and we can pass all that stuff again, but I'll just copy this here so I don't have to do it again. But now it makes things, now this function right here would do essentially what this is for us in just a much simpler code. And to make things even more easier, we can just hard code a few examples: Llama 3, Granite, and Mixtral. Essentially, the same thing, is just we're hard coding the Llama 3 and the LLM and the template passes. So now all we have to do is just call Llama 3 response, put in the prompt, and then we get our answer. It's going to properly put the prompts for us, like the special tokens we need, and everything, and it's going to properly inject that into LLM, and it's going to be very, very nice and easy. So yeah, now let's for like a little sanity check, because that was quite a bit of code. We can go ahead and copy this. This is just a simple function where we can go ahead and just run it and see what output we get from it. It's going to like run all 3 at the same time. Might take a few seconds, but it's going to take a look, and hopefully if everything works, there we go. It gives us different responses. So Llama 3 says that, capital Ottawa, and all of the responses look pretty good. They're all like, they all have their own like unique spin on it, and yeah, and they all seem correct, which is the most important part. So hey, prompt formatting is working, thankfully. Now let's go another step further. We're going to set up JSON outputs. So what if we want to actually properly return in JSON? And that could be very useful, especially for HTML pages, because right now it's just returning text, right? What if I want to return it in JSON so I can send it to my send it as data, like through a payload, that kind of stuff. And if I want different kinds of data, right, then we're going to have to just kind of do a few extra steps. Thankfully, LangChain has got you covered with that. So let's go back to model.py, okay? And we're going to import another library. This is called Pydantic. And Pydantic is a really nice validation library that will help you set up classes and help you set up just data. It's kind of like Python's data classes, but it's a couple steps. Has a bit more features than it. Technically, you could kind of do it vanilla, but Pydantic's kind of nice with that. But yeah, it can validate the data for you, and then also just process it more easily and organize it. So right now I have this called AI response from here, and for now I just put summary sentiment response And when you put it in here, they're going to be strings and string, and give a little description. This description is going to be mostly for the LLMs. So the idea is we're telling the LLM through LangChain, say, hey, here's the prompt. I want you to return it in JSON, right? But I want specifically these fields. And what are these fields? Well, summary is going to be the summary of the user's message. Sentiment is going to be a score of 0 to 100, depending on like how happy they are. And the response is like what we recommend, what you would recommend the user to do. So this could be useful for like a chat, like a customer support bot, right? Or someone like maybe for a storefront, they maybe are struggling with something. Maybe it's a technical difficulty. Maybe they want a refund or something. They're not happy. They want to give a review. Really, like you can. There's a lot of different options, and you can even add another one if you want to. Be a little fancy, just add a third one. You can add like a category if you want to like organize it and just string, and it's going to work just like that. So let's set up a JSON parser. So within LangChain, you have a JSON output parser, which takes in the Pydantic object AI response. I will just take that in, and we're going to use that in just a little bit. So now going to the get AI response, we can add that to the chain, and it'll just be JSON parser. So what are we doing now? We're taking our input, passing it to the template, it's formatting it for us, sending it to the model, and then from the model, the response of that, we will turn that into JSON, in which we can use back. So it's a few steps now. Now it's like a 3-linked chain, if you want to call it that. We will have to do a little extra stuff, like we'll have to add one more field here called format prompt. You can call it wherever, I guess. But yeah, and it takes JSON parser and say get format instructions. So what LangChain is doing for you is just it's going to describe to the LLM how it should be done. Normally, like without LangChain, you'd actually have to manually tell the LLM, like within the prompt, you have to say, hey, I want you to return it in JSON, and I want these fields, and then you'll have to have extra code that will actually manually turn it to JSON back, like when it returns, because the LLM is just going to return it as a string, right, like as text. So you're going to have to like properly parse it. And that's like really annoying to do. Thankfully, LangChain has got you covered with that as well. And when you put it all together, you will also actually have to edit with the prompt thing here. You'll have to actually add an extra field like format response, and then it will just be like probably want to put that right underneath system prompt. So you just be like that, format response. And you have to do that for all three. But since I am a little bit lazy right now, I'm just going to go ahead, just copy this, which is what the final file should look like. And we put it on here, just like that. And yeah, there is a little exercise if you want to take part into it, where you can add an extra field, like I mentioned, like category and action. If you want to play around with it, it's very flexible. But yeah, your choice. Now let's enhance the Flask app. Now we're going back to the app.py. This one here, let's not worry about it too much. It's pretty simple. You can look through the code, but essentially it just kind of takes the data, and then it will run the Llama response depending on what it's trying to do. And there will be our final file that we'll have to make, which is the index.html. This will just be a very basic, kind of ugly HTML file that we're going to use to interact with it. Sorry, my front-end skills isn't really that great. But so yeah, bear with me. Now let's test it. So hopefully if everything is working correct, we can finally execute Python app.py. It's going to run the Flask app. And let's give that a try. Yep, it's running. Okay, no crashes yet. That's a good sign. There will be a button, test your application, that you can press. If that doesn't work, you can also just go here and hit launch application. Put in 5000, because that's the port Flask runs by default, and that's what we use by default. And you can hit your application. They're pretty much identical. And hitting your application, we're going to open up the web page, and here we are, our AI assistant. So we can send the message. So I can say, I really enjoy this product, right? And then we can choose the model we want. Let's go Llama. We'll just stick to Llama 3, and we submit. Uh-oh, failure to execute JSON on response. I think I forgot a step. Oh, never mind. I think it was just loading up. Okay, there we go. But yeah, so thank you for your kind words. It gives that, takes 1.59 seconds. So there's a duration, there's the response, and there's also sentiment. So in this case, yeah, it predicted that this person who typed at me was really happy, and they're pretty positive about it. Let's see what Granite thinks about this. Yep, same thing. 95. Okay, yeah, maybe not quite the 100. Maybe Granite is a little bit more skeptical, a little bit quicker. So that's an interesting. And yeah, similar response. Let's take a look at Mixtral. Let's hit that. And yeah, 2 seconds. Some sentiment 100. User expresses. Maybe we can try. I feel indifferent about this. Please give me a refund. So give that a try. Sentiment 50. Yeah, I can expect. Sorry, you're feeling indifferent. I can help you process a refund. Please provide your order number for further assistance. So yeah, pretty much what you might expect an AI assistant would have to do. Again, this is more like a general AI assistant. It's not going to actually process any refunds. But as you can see, like there's a lot you can go with this. There's like this is really just scratching the tip of the iceberg on how you can make an AI assistant and how you can like create modular code that uses different LLMs and how they can work together for like just to kind of really achieve what you're trying to do. So this is pretty much the end of the session. There is going to be an extra page at the end where you can like some key takeaways of what you've learned and next steps. So if you really enjoyed this and you like this environment, I would definitely recommend checking out some of Cognitive Class's other courses. We have like well over 100 courses, and there's even a few other ones that I would actually recommend taking as well. Let me first AI. There's kind of another one I actually would recommend. I'll put it in the chat if you guys are interested in a bit. I'll find it and I'll send it to you, but it's kind of like I'd say like a spiritual successor to this one, where we kind of take it a step further. We implement something called LangGraph, and we do a few more fun things, especially that one even like takes in like images and processes images and like uses that to determine how busy a cafe is and changes the price accordingly. So if like a cafe is really busy, there's a lot of foot traffic, it might increase the price. If it's very light, might decrease the price to kind of try to maximize revenue, that kind of stuff. Sounds a little dystopia, but it's a cool project, trust me. And yeah, I guess that's it for the session. It seems like we have a little bit of time. I'd be more than happy to answer any questions from anybody. Yeah. Would the work here be also able to be integrated into things like GUI apps? Yeah, 100%. So everything I taught you here is very, very, very general and can be used in pretty much everything. Like the Flask app that you saw here is very basic. So we're using like the LLM, the model pi, the config pi, all of that stuff here has nothing to do with Flask. Like Flask doesn't know kind of doesn't really know it exists. Flask is just really just this file here and just really just this route. So and all we're doing is just calling that, turning to JSON. And since JSON is just so flexible, we can use that and use it on anything. So it doesn't have to be a website, but it can also be a desktop app. You can run it on the cloud. It can be like an API endpoint that you just call online, right? So yeah, you can. Yeah. So as long as like you're hosting it online, you can run it anywhere, even a mobile app. Like if you like to use something like React Native, I've done that a few times. It works very nice. So let's see. As an end user, ChatGPT, I am surprised I have received responses which have seemed to convey empathy as part of a response. If appropriate for this session, could you explain how empathy is coded and what is in my inquiry might trigger such an enhanced reaction? Do you mean like the sentiment thing? Well, a lot of the AI stuff is kind of like a black box, so it's kind of like hard to really say exactly like how the AI does it. It really depends on the training data. So it's not really super deterministic. And I'm sure if I run even the same prompt multiple times, we'll probably get slightly different values of sentiment because, yeah, I can't really like determine how happy a person, I can't even determine how happy a person is through reading like just a sentence. But it just does that to like just kind of predicts it. So there's probably like through the training, it knows what is a positive phrase, what is a positive sentence, what are positive words, and knows what isn't, right? Especially some of the more advanced LLM one, like Llama with 70 billion parameters. I'm sure like a few hundred at least are related to like some kind of sentiment to know, or like positive language words, negative words, that kind of stuff. So really, it all depends on the parameters and the input data. How long will these cognitive classes be up? Well, I'm happy to tell you that they are going to be up for as long as possible. Like we have no plans of shutting it down. This is cognitive class is an IBM initiative that we started quite a few years ago. And this is something that we all work on. Like this is something that I even actually like actively maintain on a daily basis, and because we believe education and learning should be free for all. And even for a lot of our courses, we provide certificates, like official like IBM certificates, not the guided projects like this one, because this is a little bit too short to like give a full certificate on. But for some of the courses, we do actually give proper certificates if you're interested in that. And a lot of them will be made by myself. Or like I don't make too many courses, but I've made like a couple, as well as many of other people that are in the team. So a lot of these courses are actually made in-house by us, which is kind of cool. And yeah, we do everything from like creating, maintaining, and even like providing the content. And we have an incredible team of data scientists. Right now, like Kunal and Karen, they're like on the stream right now helping me out with some like technical stuff and answering questions. And they also make a whole lot. They're more familiar with the content creation. They're like true experts on this. How long? Oh, can this be used with Express.js? 100%. I've done multiple projects with Express.js. I love Express.js personally. And yeah, these can easily be done with Express.js. LangChain has an Express.js in the documentation. I should probably show. I'll see if I can send the link. But yeah, if you just type like LangChain on Google, it will be the first result. You can see documentation, and you can see it has Python and JavaScript. You're going to obviously want the JavaScript for Express.js. And yeah, and the support for it is really great. There's even like IBM watsonx support for that. That even some people on our team, we actually like code for IBM. We do a lot of like open source development for the LangChain JavaScript implementation. So yeah, Express.js is a really good framework. And yeah, everything about this is very framework agnostic, I suppose. So yeah. And yeah, I think that's all the questions. I really hope you had a great time. This has truly been an honor on my end, and I'm very proud and privileged to be standing here before you, showing my guided project.